Imagine possessing an extraordinary power that allows you to aid nearly every individual on planet Earth. However, there's a catch. You're confined to your hometown due to the peril of potential assassination. This situation is undoubtedly peculiar and profoundly unjust. Meet Thomas, hailing from Switzerland, who was bestowed with this unique capability from birth. Throughout his childhood, his parents prohibited him from attending summer camps or even strolling through the woods, all in the effort to shield him from any traumatic experiences. Consequently, he now limits his visits to locations equipped with medical facilities to ensure his safety. Central to this narrative is Thomas's distinctive blood, a rarity akin to a winter thunderstorm. Remarkably, only 1 out of every 200 million individuals possesses this blood type. The question arises, is this phenomenon a blessing or a curse? In ancient times, individuals possessing special blood were often branded as sorcerers and subjected to burning. Even today, a certain mystique surrounds blood, leading to the attribution of magical qualities to it. This story delves into the intricate intersection of scientific knowledge and myth, illustrating how our fascination with blood has engendered both erroneous beliefs and groundbreaking revelations. In this video, you will find out in whose veins flows the mysterious golden blood. Can your blood type offer insights into your personality? Is it feasible to substitute blood with synthetic alternatives? Why does the prospect of cross-species organ donation remain unattainable? How can one endure without a solitary drop of blood? Lastly, what modern fears might vampires harbor? In the era of our distant ancestors, the understanding of blood was limited, often considered forbidden knowledge. Instances where blood was visible included childbirth or wounds, moments intertwined with the concepts of new life and mortality. Thus, blood became a symbol of nature's dual nature. The Greeks illustrated this duality with the Gorgon, whose blood from one side was believed to possess healing properties, while the other side was associated with death. Similarly, the Romans of antiquity held the belief that consuming the blood of a freshly slain gladiator could transfer his life force. If one desired the might and swiftness of a beast, the solution was to ingest its blood. Seeking to elude death's grasp, the answer lay in consuming the blood of young boys. Notable figures such as Louis and Pope Innocent ventured down this path. Surprisingly, these practices were genuinely conducted by individuals. Even the Pope of Rome, a figure of great sanctity, partook in blood consumption. However, ancient physician Galen in the 2nd century contested the sanctity of blood, asserting its applicability in conventional medical practices. At this point, you might be inclined to believe that at least one rational perspective existed, yet it's wise not to rush to conclusions. Galen proposed a theory that shifted the locus of control for our emotions and actions from the brain to 4 primary bodily fluids: blood, mucus, and 2 types of bile. The dominant fluid within an individual determined their behavioral tendencies. An abundance of blood, for instance, was associated with heightened cheerfulness and positivity. However, Galen also posited that an excess of blood could lead to illnesses. Galen's theory set the stage for a medical practice that endured for 1,500 years, a practice known as bloodletting. Bloodletting was seen as a universal remedy in perplexing situations. Whether one suffered from a headache or chest pain, the solution was simple: open a vein. Incisions between the eyebrows were prescribed for headaches, while veins beneath the tongue were targeted for chest discomfort. Who do you think was called in for these procedures? Instead of skilled healers, it was barbers who undertook this role. During that era, barbers had a surprisingly broad range of duties, including tooth extractions and even amputations. The church prohibited monks from engaging in such practices, leading to barbers assuming these medical tasks. The implements used for bloodletting had a menacing appearance, resembling tools of torture. Tragically, this practice contributed to the demise of George Washington, the inaugural president of the United States. In his case, more than half of his blood was drained in an attempt to alleviate a sore throat. As for today, bloodletting is largely obsolete in medical practice. Do they do bloodletting now? Yes, they do, but in an even more ancient way with leeches. The thing is that they inject into the wound special substances that do not allow the blood to clot, making the blood quickly run through the vessels, revitalizing the area around the bite and relieving blood stasis. This is the secret of leeches. Therefore, with varicose veins or after plastic surgeries is the best thing to relieve all swelling. Leech will cling to you 3 of these jaws, but will do everything reliably, and the blood is pumped by its entire body as a pump. A leech can become 8 times heavier in one go. What's not cool is that people used to bleed everything. Then just imagine in the 17th century, medicine was like the 2nd century. Why? What's the reason? Was it because everyone was stupid? No. People knew anatomy, but they didn't know physiology. They could cut open a corpse and see what we're made of, but they didn't understand how it all worked. Did you know where blood comes from? Blood is made in the brain. Well, in the bone marrow. Inside the bones, from stem cells, the bone marrow sculpts any blood parts, white blood cells, red blood cells, platelets, depending on what the body needs. Diving deeper into the topic, the evolution of scientific understanding sheds light on intriguing revelations. Once, scientists held a rather curious belief that blood was derived from food. This peculiar notion posited that food underwent a transformation into blood, which the body subsequently consumed. Consequently, it was thought that if someone experienced blood loss, they could simply replenish it by consuming food. This view underwent a substantial transformation due to the groundbreaking work of a physician named William Garvey in England. Garvey, a true outlier of his time, embarked on a pioneering journey. He meticulously compared the quantity of blood within animals to the volume of food they ingested. Surprisingly, he consistently found that the mass of blood exceeded that of the food, challenging the prevalent idea that blood originated from digested sustenance and subsequently dissipated throughout the organs. Garvey's findings painted a different picture. Blood was not a disposable product, but a recyclable resource, continually circulating within the body. His revolutionary insights were even demonstrated to King Charles I through live patient demonstrations. Following these breakthroughs, a collective realization dawned upon the scientific community. Blood wasn't just a consumable, but an invaluable one, demanding preservation. On average, the human body houses approximately 5 liters of blood. Losing even a fraction of this volume would significantly impact the pressure within the circulatory system, necessitating restoration. This newfound comprehension ignited a fervor for experimentation during the 17th century. This period witnessed a frenzy of unconventional trials, wherein substances ranging from milk, plant juices, wine, beer, and even urine were attempted as potential blood substitutes. Eventually, the concept of utilizing animal blood emerged as a potential solution. Initial trials involving lamb's blood yielded promising results, with patients experiencing improvements. However, a troubling shift occurred as fatalities started occurring after transfusions. The fluid component of blood constitutes a solution composed of salts, proteins, and essential nutrients. In scientific terms, this mixture is referred to as plasma, housing a variety of cells, each with distinct roles. Erythrocytes, also known as red blood cells, function as oxygen and carbon dioxide transporters, akin to truckers on the road. White blood cells, termed leukocytes, act as the body's defense, akin to law enforcement targeting intruders. Accompanying them are the diminutive platelets, serving as repair workers to mend damaged blood vessels. Each of these cells bears unique proteins or polysaccharides on their surface, designated as antigens. But what exactly do these antigens serve for? Let's picture the organism as a city or even a train station. In this bustling environment, a variety of cells are in constant motion. Your own cells, unfamiliar cells, and more. Acting as the law enforcement are the white blood cells, akin to the police, diligently inspecting the antigens. Upon detecting such foreign entities, the immune system initiates a specialized operation against them. This scenario extends beyond just viral invaders, as shown on the current display. and even includes scenarios like transfusion of blood cells from another individual. Remarkably, red blood cells feature an array of over 300 different antigens. Here's where things get a bit intricate. There are two primary kinds of white blood cells, referred to as type A and type B. It might appear a tad convoluted at first glance. The underlying principle is that various individuals can possess diverse combinations of these antigens. For instance, if only the A antigen is present, the blood type is categorized as type 2. On the other hand, if solely the B antigen is detected, it falls under type 3. Should both antigens be present simultaneously, it corresponds to type 4. Conversely, if neither antigen is found, it's categorized as type 1. The significance of this intricacy stems from the fact that your immune cells are rather selective, exhibiting a certain disdain for foreign substances introduced into your bloodstream. This aversion is precisely why, from birth, they're equipped with defenses against unfamiliar antigens, represented by molecules termed antibodies. Visualize antibodies and antigens as akin to two halves of Velcro, one featuring hooks and the other loops. Notably, each antigen matches with a specific kind of antibody, forming a binding partnership. Consider antigen A, for instance. It pairs exclusively with an antibody named anti-A. Similarly, for antigen B, the corresponding antibody is anti-B. The interaction between these two is somewhat akin to puzzle pieces fitting together. As for the letters absent on the surfaces of your body's cells, your immune system has deployed traps in the form of antibodies to counteract them. The underlying concept is straightforward. If you don't match our profile, we'll mount an attack against you. If your cells only carry antigen A, your immune system will react against antigen B, facilitated by the presence of anti-B antibodies. The reverse also holds true. If the cells carry antigen B, there will be anti-A antibodies present. However, blood featuring both antigens A and B can coexist with any blood type. It recognizes and accepts both antigens A and B. Consequently, there are no antibodies directed at other blood groups. Conversely, blood devoid of antigens A and B will react aggressively against any blood group except its own. When blood containing incompatible antigens is introduced, the red blood cells aggregate, adhering to each other with these stickies, ultimately causing the blood to thicken and obstruct blood vessels. This adverse outcome could result in death or, at best, complications such as kidney failure. In addition to antigens, the rhesus factor is another type of antigen known by the code name D. This particular antigen operates in a slightly distinct manner. If absent, you possess Rhe-negative status and lack antibodies against it. However, you can develop antibodies to it when introduced to rhesus-positive blood. Initially, the body pardons and merely memorizes the foreign entities. Yet, subsequent immune exposure melds them together, endangering your life. This establishes the rule of compatibility. Fourth positive can receive any blood type, but the donor can become only for itself. And first negative serves as the universal donor, but can only accept the same first negative. Nevertheless, a complication arises as scientists prolong the breakdown of blood into molecules, leading to the identification of an expanding array of blood types. The scope extends beyond the initial 8 blood types, reaching into the thousands. That's how many different combinations can be made from 300 antigens. The terms displayed on the screen encompass not solitary categories, but entire clusters of groups. The rhesus factor, surprisingly, isn't just a single entity, but comprises 60 distinct factors. Consequently, hospitals aspire to acquire a supply of blood that could suit a broad spectrum of recipients. This universally compatible blood is known as golden blood, a genuine rarity. It lacks any of the 60 H factors that might trigger compatibility issues during transfusions. Remarkably, only 43 individuals across the globe possess golden blood. Among this select group is Thomas, introduced at the outset of this discussion. However, for the carriers of golden blood, it brings a paradoxical predicament. They can only receive blood from fellow individuals with golden blood. Yet, the reason for this complexity remains elusive as scientists continue to grapple with an exact explanation. This knowledge gap has spawned various myths, such as in Japan, where blood types have assumed significance akin to zodiac signs. The Japanese believe that blood type exerts an influence on one's personality traits. For instance, those in blood type 1 are considered ambitious, albeit brusque, while those in type 2 are seen as meticulous and cautious. Type 3 are seen as passionate yet irresponsible, while those in type 4 are perceived as rational yet indecisive. This cultural significance is so pronounced that individuals in Japan often display their blood type on their Facebook profiles. The market even offers blood-specific products, such as ribbed condoms for the second type and delicate pink condoms for the first type. In a unique twist, certain companies factor in blood type when making employee selections. This practice escalated to the point where one minister attributed his poor decision-making during the Fukushima accident cleanup to his unfavorable blood type, implicating type 3 for his lack of responsibility. A comprehensive experiment involving 10,000 participants revealed that blood type accounted for just 0.3% of their personality traits. Hence, blood type doesn't elucidate one's character. It can influence susceptibility to diseases. For instance, the malaria-causing pathogen Plasmodium falciparum cannot infect type 1 red blood cells. Consequently, most indigenous populations in regions like Africa and the Americas, where this parasite is or was prevalent, predominantly possess the first blood type. This prevalence suggests that evolution has enabled individuals with compromised immune systems to survive and reproduce in these areas. Blood types likely evolved as an adaptation to combat microbes. Multiple theories regarding blood's evolution exist, with one positing that the original blood type was type 4, characterized by both antigens. Over time, evolution eliminated these antigens sequentially, leading to the emergence of groups 2 and 3. Eventually, when both antigens disappeared, the first blood type materialized. Herein lies the predicament. Curiosity is an intrinsic part of who we are. We ventured beyond transferring only our own blood and crossed into the realm of animal blood transfusions. Is it compatible? Yes, but not from all animals. Surprisingly, our dogs possess one of 8 distinct canine blood types that don't align with our own. Infusing a substantial amount of their blood could trigger a catastrophic immune response, leading to cellular breakdown. If you take a donor among animals, then doctors will be much better suited. You'll never guess. The blood of the lugworm. The blood of the sandworm closely resembles ours, yet it lacks any antigens. This unique trait renders sandworm blood universally compatible. Remarkably, it also boasts the capacity to absorb a staggering 40 times more oxygen than our own blood. During the pandemic, researchers tested its efficacy on severe COVID-19 patients to enhance oxygenation. From this exchange of blood between species, a groundbreaking concept emerged. Consider the prospect of engineering synthetic blood that suits all blood types. The task is simplified by the fact that artificial blood need not precisely replicate real blood. Its primary purpose in life-saving scenarios is to restore volume, maintain vascular pressure, and facilitate extensive oxygen transport. Let's delve into the intricacies. How might volume be restored? One method involves infusing salt water, often referred to as saline. Alternatively, coconut water could be employed. Interestingly, coconut water served as a makeshift solution during the Second World War. While this approach was considered a last-ditch effort due to coconut water's sterility, modern medicine deems it somewhat primitive. Returning to contemporary scientific endeavors, let's explore a more conventional path. Imagine we've replenished volume with saline. Now, the key question: how will our substitute effectively transport oxygen? In our natural blood, the duty of oxygen transportation falls upon hemoglobin, the very component that imparts the crimson hue. Here lies the solution: incorporating hemoglobin into the synthetic blood. Indeed, it's akin to resembling the surface of Mars. The iron present in its soil reacted with oxygen over time, resulting in its distinctive red hue. A parallel phenomenon occurs within our blood. Hemoglobin engages with freshly inhaled oxygen, causing a vibrant red coloration. However, injecting pure hemoglobin triggers poisoning and could lead to a heart attack. Crafting a viable blood substitute requires ingenuity. Scientists harvest hemoglobin molecules from expired donor blood and encapsulate them within protective polymer shells. This ingenious shell allows gases to permeate, facilitating oxygenation of the blood, while securely retaining the hemoglobin molecules. It's analogous to concealing silica gel packets from shoeboxes within a bag. Air flows through, but the gel remains contained. This technique avoids heart attacks and maintains a harmonious balance. Supplying the heart with oxygen via either blood or substitutes allows it to function for hours outside the body. If supplemented with nutrients, it can continue beating even longer. The ongoing exploration of blood has led to the development of blood substitutes. However, an inherent limitation persists. Current artificial blood lacks the ability to coagulate and will consistently flow from wounds. Blood has proven to be more intricate than our previous perceptions. To be more precise, blood stands as the most intricate bodily fluid, comprising numerous cell types, hormones, and antibodies, all forming a comprehensive mixture. However, what's intriguing is that there are instances where individuals can endure without a single drop of blood. And this can even be a life-saving measure. When an individual with severe injuries arrives at a medical facility with only moments before potential death and insufficient time for surgery, they can be induced into a state of anabiosis. During this state, the heart ceases beating, the brain enters a dormant state, and cellular processes halt. The University of Maryland has proposed an innovative approach, replacing the patient's blood entirely with a cold saline solution, internally lowering the body's temperature to around 10 degrees Celsius. This provides medical professionals with an additional 2 hours. This extra time allows for the proper treatment of the victim, such as extracting a lodged bullet or suturing damaged arteries and lungs. In cases of severe accidents where bones need realignment, this method also proves effective. Subsequently, the body is gradually warmed, initiating the circulation of blood within, and the heart resumes its natural rhythm, either autonomously or through external means, like electric stimulation. In the absence of such cooling, the brain would succumb within 5 minutes, following the cessation of heart activity. But what if, instead of a one-time infusion of cold liquid, a continuous renewal of such a solution were administered? Could this potentially enable the maintenance of human hibernation for extended periods, perhaps even months? While this might sound like a work of fiction, it's worth noting that many groundbreaking ideas begin as fanciful concepts, just like this one. Furthermore, it represents an initial and tentative stride towards concepts such as cryogenic slumber. As we approach the realm of such technological possibilities, it's remarkable that a significant number of people still adhere to beliefs and notions like bad blood influencing character or rejuvenation, as well as the practice of blood transfusions and similar notions. In the rural villages of Nepal, even in the 21st century, menstruating women are banished from their homes and forced to take refuge in huts located on the outskirts, often lacking windows, doors, and electricity. These huts can be damp and cold. This practice stems from the belief that the presence of menstrual blood could bring ill fortune to the entire family. Remarkably, developed countries also grapple with similar issues, appearing to regress to the attitudes of ancient civilizations like the Romans. A parallel example lies in the United States, where thousands of individuals identify as modern vampires. They assert that consuming human blood alongside regular sustenance alleviates fatigue and headaches. In more extreme cases, the situation worsens.
It excites me, it arouses me, it makes me feel like everything is just perfect for a tiny little second.
Medical professionals generally attribute such practices to the placebo effect, suggesting that individuals are influencing themselves. I must convey some unsettling news. For anyone considering reenacting this and embracing a vampire identity, consuming large quantities of blood is dangerous. The body struggles to eliminate excessive iron, which accumulates in the liver until its function deteriorates. This underscores the fact that genuine vampires would not exhibit a pale and radiant appearance, but rather a jaundiced or brownish hue due to liver complications. It is therefore wise to place trust in science rather than embracing mysticism. And as always, pump your brains as hard as your heart pumps your blood.